In this model, we're going to take a look at rework and how that impacts a system, and we're going to do that using an IDEF0 model. Okay, IDEF0 is a standard that was developed by the U.S. government for process mapping. It's hierarchical in nature. So if you look at this graph here on the right, you start with a very high-level view of your system. You define its boundaries. Then you go and you detail it out. And then each level of those details can be further detailed and detailed. A typical model of a real system might go 4 to 6 levels down, and pages typically will have between 3 and 6 activities per page. So if you want the activities, and they're called functions in IDEF0, are represented by a box, and an input comes in, an output goes out, controls come in from the top. A control could be maybe the handbook or the documentation or regulation that you're following, and the mechanism typically is what does the work. Would be a resource, either a person or a machine, either one like that. So that's IDEF0 at a high level, and I recommend that if you're interested in this, that you go take a look at it. IDEF0 is very useful for mapping out very big systems. This hierarchical nature, you could do hundreds, even thousands of different activities where it doesn't show some of the cool stuff that a value stream map shows, but it can handle a much, much larger model and a more conceptual model. So here's a typical page that you might get in an IDEF0 model. In this case, I gave it the motif of a mortgage company, perhaps. Maybe the customer applications come in, then a loan processor will verify the information supplied by the customer. Then they'll use that information to the loan processor will determine the rate and the terms of the loan. They'll go ahead and assemble a package, and if everything is in good order, then it goes on to the next step. And if it's not in good order, then it loops around and has to be redone. So from a lean perspective, I'm sure everyone here is noticing, hey, anytime you get a loop back, that is not good. That's definitely something that someone with lean experience is going to focus on, because rework is definitely a big source of waste. So what could we do about that? Now, the IDEF0 standard is, when you make a model, it's a static model, just like a value stream map is a static model, meaning it's not simulated over time. It doesn't look at that aspect of things, but we can do that. There have been companies that have taken IDEF0 and they added additional information and created simulation models from it. Meta Software comes to mind as the company that did that. And what we can see in this example, I had to give it information that goes beyond the IDEF0 standard, because that alone is not enough to give the details we need to do a computer simulation model. But let's look at some of the additional information I gave. Let's say we have arrivals come in, so the applications, 6 to 7.5 seconds per application. And let's say we have 2 people doing the loan processing, so 2 loan processors. And let's assume that when they start a step that they do all 3 steps sequentially, okay, that they hold on to that work. And keep in mind, this is not a physical layout. It's a process model. So they could be sitting at one desk doing all 3 of these items. And also, let's assume that the rate of not in good order is 15%. And that all 3 of these steps take 3 to 5 seconds each. Now, minutes or some other time unit might be more realistic, but I just want to make a convenient simulation model for our training exercise, so I just selected seconds. So I could go ahead and simulate that, and I'll let you see my control so you can see what I'm doing. And we could go ahead and start it up. And in this case, I don't show the physical orders coming in. Originally, I started to. I had little folders going through on the things, but then I thought, someone might misinterpret that as, that they're being physically moved when they're not. and I'd be having to add in times that really were not there. So I removed that particular animation from this, even though it looked really cool, and I kept it more conceptual. So here we can see that we've got 33, 34 came in. There's 9 in the queue, and this says how many are processing. Now there's 2 processors, loan processor people, so it'll never be more than 2. If we ever pause it and add up all 3 of them, there'll never be more than 2 being processed at a time, because we're constrained by the number of people doing the loan processing. So I'm going to go ahead and speed this up. Let's see what happens in the long term. So we're seeing that we got 2,000 came out. We've reworked 400 or 500, and that the time in the system from when it comes in to when it finally leaves is going up and up and up, and the queue is growing infinitely. So this is telling us that at 15%, I'm going to go ahead and pause it. I think we've got everything we need. At 15%, we are not keeping up with our customer demand. So obviously the rework is probably contributing to that. So let's go ahead and see if we can do a lean project. And if you were to Google not in good order or in good order loan processing, you will see lots and lots of reasons this could happen in a real system. It could be something, maybe they're using an old database, and when they go to verify things, it's outdated, that kind of thing. So there's definitely a lot of places you can go and improve things in a system like this. So let's take it to the other extreme now, though. Let's say instead of 15% defective, we go with 0% effective. Okay, and here's how we can change this number in my model. You could go ahead and right-click this and say Input Editor, and it opens up this box here. And this says the good rate on the last line here. That's the good, in good order, and this is not in good order. And they have to add up to 1. So if we want 100% in good order and none that are not in good order, you enter it there. Then you click on some other line or you hit enter just to make sure that it registers. Close the box, and now when we run it, we'll be using the new rate. So let's go ahead and let's go start it now. And now with the new values, wow, what a difference. You know, it only was 15% that had to be redone, but it made a huge difference. Now it's keeping up with no trouble at all. So we're holding real steady at 12.1 seconds. There's hardly no queues. Sometimes we might momentarily get one for just a moment. So very cool. If you want to play with this, go ahead and play with it. For example, if you want to figure out how low do we need to get the rework rate down before our system can keep up. Okay, that would be a good one. Go ahead and you could play with those numbers and see what you get. Obviously 0 is the best. You may not be able to do that in a real system, but that's ultimately the goal. Okay, so with that, I hope you enjoyed the model.